So this is a demo of the use of Adams software in creating a simulation model. The model displayed here in the video is the simulation model based on the study of Cagalpin et al., their fabricated pipe inspection robot. So first, the simulation model was modeled directly in Adams, so it's here, and the mass was defined like this. For example, here in the chassis, it was defined by user input. This is what is displayed here is part of the total weight of the robot as stated in the paper. And for example, here in the wheels, it is defined by the mass is defined by geometry and material type, and it is shown to be rubber since that is what is used in the physical prototype. And here in the pipe, the material is steel as it was the material used in the testing of the previous study. So moving closer, here is the here is a closer look on the joints and other constraints. So first is the fixed joint. So this fixed joint, as stated in the paper, connects two parts and keeps them still together. So as the icon of the fixed joint implies, it just serves as a lock. So the pipe here is locked to the ground, so it wouldn't move. It, so it wouldn't fall. Next is the revolute joint, and on a closer inspection, it is connected to the it is connected to the leg. The wheel is connected to the leg of the robot through the revolute joint, since that's how the wheel should move. So this is the revolute joint, and you'll need a revolute joint before you can actually input the revolute joint motion. So this is the revolute joint motion. Next, next is this one, the spring, the translational spring damper. This is used to connect the leg of the robot to the chassis, since that is what is used during the physical prototype. And you can modify the parameters of the spring here. So you can just so as stated in the paper, this one has no damping, and in the paper of the previous study, here is the actual free length of the spring, and at the free length, the preload force is 0. And lastly, here is the contact force. This is what connects the solid to another solid. In this case, on what is viewed in the screen, this specific contact force connects this wheel to this this pipe. So once the constraints are complete, the joints, the joint motions, the forces, you can now proceed to the simulation, the motion simulation using using interactive simulation in the simulation control. So just input the end time and the step size. Be careful when choosing what to input in the step size and the end time, because sometimes the simulation cannot run or can get an error just simply because of the inputted value in the end time or step size. So just by doing this, actually this would take a while because the software, oh, there it is. So just wait for the simulation to finish, and after that you can view the results in Adams post processor as stated in the paper. So this one is set at 3 seconds, just like in the previous study. Okay, now once that is done, you can go to the simulation control, or actually it's already open here in Adams post processor. For let's clear the plot first to check the results, and let's clear here this one so we can load the animation there. So we can go here to the plot, and we can choose which characteristic to check from the simulation. So as said in the validation method, we need to check the velocity of the model to see if it matches the physical results. So here we can check the velocity. We can also check for the position or displacement, and we can check using this plot tracking to check the maximum and average values. So for the velocity, it's at 135.3139, and for the displacement, the maximum displacement traveled by the simulation model is 407.11585 millimeters. And here also you can check the movement of the simulation to see if it has any problems. But in here, I recommend that you use the wireframe option instead to get to get a much clearer view on what's happening inside the materials during simulation. This would be mostly used the wireframe view in the checking of the mechanical motion of the springs when analyzing the design of these studies in pipe inspection robot. So you can check the views and just see if there are any problems, and if not, then good, you're good to go. So that's it for the demo.